Welcome to this video on load flow analysis. In this video, we shall continue with our learning outcome number 3, that is load flow by Gauss-Seidel method. So here is given the flow chart for load flow using Gauss-Seidel method. So we shall see how load flow is performed using Gauss-Seidel method in the form of flow chart. So first it is the first we have to get the input of our system. So what all data we require for load flow analysis of the system, here it is given. So we have to read how many number of buses are there in the system. Okay, in the previous example we have taken 3 bus system. Then we have to read how many lines are there, what are the interconnection, and what are their impedances. Along with self impedances, we have to take line charge admittances, and if there are any mutual impedances, so that also we have to read. So entirely we have to read the transmission network data. Then regarding the bus information, bus data, so read slack bus voltage. That is, as we know that at the slack bus we specify the voltage. Then for load buses we have to read what is the active power and reactive power specified for that bus. For generator bus we have to read what is the active power specified and what is the voltage specified at that bus. Along with that, if there is an reactive power generation limit, that is Q max and Q minimum for that particular generator. So these all data we require for the given system. Along with that, we require a convergence criteria, that is epsilon. So that also we can mention over here, that up to what decimal places we require accuracy of our result, that is what we call it as convergence criteria. So that also we can take as an input initially. The next step, after reading all the data of the system, then we have to form a Y bus. So this Y bus can be either formed by inspection method or by singular transformation method. But Y bus inspection method will not be applicable if there is a mutual admittance between the transmission lines. After that, after forming Y bus, then we have to set voltage. We have to make an assumption. So here it is given, set 1.0, that is a flat start. We have to assume voltages for PQ buses, and we have to assume the phase angle also for the PV bus, and then we have to start the iteration count. Now we have to start with the calculation. So the first iteration, it is now written as k equal to 0. Now start with the bus count, p is equal to 1. Now first we have to check whether our bus is slack bus or what. Okay. Now obviously in most of the problem the first bus is obviously taken as slack bus. So in some time we can avoid, we can start here the bus count as p is equal to 2. So there is no necessity of checking any slack bus. We can directly go to second bus checking. So that can be avoided, but now in this flow chart it is given as check for slack bus. Now yes, if it is yes, then we have to go to D. We will see where this D goes. Directly it will go to our checking whether is it the last bus or what. So this will go to, we will show, I will show you where it goes. Next, after checking if that is not a slack bus, then we have to see whether it is a generator, sorry, whether it is a generator bus or PQ bus. Now if it is a generator bus, that is if it is a PV bus, then we have to calculate the reactive power as we have done in the problem in the previous video. You calculate the reactive power by the appropriate equation. After calculating reactive power, we have to check whether the Q what is calculated, if it is less than P minimum. If it is less than P minimum, then we set that reactive power limit, we set the reactive power for that bus to Q minimum, and we proceed for the calculation of voltage. So here it is written, set Q is equal to Q minimum and treat this bus as load bus and go for the calculation of voltage. So here we can see that calculate the voltage for that bus. Okay. Now if not, if our Q, what is reactive power generation, what you have calculated for that bus is more than Q minimum, and now we have to check whether it is more than Q max. If it is more than, here it is written Q minimum, please correct it. If it is greater than max, then we have to set, if it is yes, then we have to set it to the maximum reactive power generation, and we have to treat it as load bus, and then we have to proceed for the voltage calculation. That is what we have done the similar procedure in our problem also, in the second problem, PV bus. Now, if reactive power V, if it is found within the limit, then we will come to this point. Now, treat bus as generator bus and calculate the phase angle. So, here we have using the appropriate equation, we have to calculate the reactive power. Now, now there is okay. So, okay. So this is what, if it is a PV bus, we have to deal it with like this. Now here in this case, what is there? If it is not a generator bus, that is what here it is. If it is not a generator bus, then this point, it is a PQ bus, then we have to calculate its voltage. So this point directly comes here. So this point comes here, then we calculate the voltage. If it is a PQ bus, and then sometimes the voltage whatever it is calculated is accelerated, so that, so as to reduce the iterations. Okay, so that is one more point we can accept as an input. Here we can accept the acceleration constant coefficient alpha as an input. Okay, so after calculating the voltages, now uh, now we have to see that whether our bus, what we have done the calculation, if it is a last bus or not. If it is not a last bus, then we have to go to C point. So this C point comes to at this point. So we have to check whether it is a slack bus. So it is again, the iteration will begin, it will check whether it is a PV bus or it is a PQ bus, and appropriate calculation will be done. Now, if it is a last bus, so if you have done all the calculations for all the buses, then you have to calculate delta V max. That is the largest, as we have seen, we calculate the difference vector, difference voltage vector for each of the buses, and from that vector you have to find out the maximum difference vector delta V max, and if delta V max, if it is less than tolerance, if it is yes, then it is understood that whatever results we have obtained for the voltage at the buses, that is all correct values, Then we have to proceed with the line flows and slack bus power, and then we have to print the result and stop. If not, then we have to proceed. If our delta V max is not less than tolerance, it means that we are not reached to the final correct values. Still more iterations are required. Then we go for the next iteration to B. So this B, it will go here. I will show that this B will come over here. Now again you start with the second iteration. So these two loops, one for the bus count and one for the iteration count. So this is how load flow is performed using Gauss-Seidel method in the form of flowchart. We can convert this flowchart in terms of logarithm also. Uh, okay, so in this video up to this only. In the next video we shall continue with the Newton-Raphson method. So thank you very much.